Good morning, ma'am. I'm Sarita from ECE department. I'm pursuing my BTech first year in Srinivasa Ramanujan Institute of Technology. Today I'm here to explain about Z parameters in terms of H parameters. Introduction to Z parameters and H parameters. Z parameters and H parameters are essential for characterizing linear electrical networks. Z parameters describe the relationship between voltage and current in terms of impedances. H parameters, on the other hand, represent a network's behavior in terms of hybrid parameters. Definition of Z parameters. Z parameters or impedance parameters relate voltages and currents at the ports of a two-port network. They are defined as Z11, Z12, Z21 and Z22, which represent the input and output impedances. Z parameters are particularly useful for analyzing circuits with known impedance values. Definition of H parameters. H parameters or hybrid parameters combine both voltage and current characteristics in a two-port network. The four H parameters are H11, H12, H21 and H22, which describe input impedance, output admittance and more. H parameters are often employed in transistor circuit analysis due to their hybrid nature. Conversion between Z parameters and H parameters. The conversion between H parameters and Z parameters is essential for circuit analysis. A set of equations relates the two parameter sets, allowing easy transformation. This conversion facilitates the design and analysis of circuits using their parameter set. Z parameters in terms of H parameters. The equations to express Z parameters in terms of H parameters are straightforward. The formulas Z11 equals to H11 and Z22 equals to H22 minus H12, H21 by H11 relate the parameters directly. H parameters in terms of Z parameters. Just as Z parameters can be expressed in terms of H parameters, the reverse is also true. The equations H11 equals to Z11 by Z11 plus Z22 and H21 equals to Z21 by Z11 plus Z22 provides the relationship. Understanding this conversation is vital for flexible circuit and modeling. Practical applications of Z and H parameters. Both Z parameters and H parameters are used in various and electronic appliances. They are particularly useful in RF and microwave engineering for analyzing amplifiers. Knowledge of these parameters helps engineers optimize circuit performance. Advantages of using Z parameters. Z parameters simplify calculations in circuits with passive components and matched loads. They provide insight into input and output impedances, which are critical for design. Their direct relationship with voltages and currents enhances usability in analysis. Advantages of using H parameters. H parameters are advantageous when dealing with active devices like transistors. They effectively encapsulate both voltage and current relations in a compact form. Their hybrid nature allows for easier integration in circuit simulations. Conclusion. Understanding Z parameters and H parameters is crucial for electrical engineers. Both parameter sets provide insights into circuit behavior and performance. Mastery for conversion techniques between these parameters enhances analytical capabilities. Feel free to modify any of the party representation as Z parameters and Z H parameters. So now I'm going to share you an equation of Z parameters in terms of H parameters. The general equation of Z parameters is V1 equals to Z11 I1 plus Z12 I2. V2 equals to Z21 I1 plus Z22 I2. Now I'm taking these both equations as 1 and 2. General equation of H parameters is V1 equals to H11 I1 plus H12 V2. I2 equals to H21 I1 plus H22 V2. Now I'm naming these two equations as 3 and 4. So from equation 4, H22 V2 equals to I2 minus H21 I1. V2 equals to 1 by H22 I2 minus H21 by H22 by I1. Now I am replacing the equations. V2 equals to minus H21 by H22 I1 plus 1 by H22 I2 as fifth equation. Now I am substituting the V2 in third equation. V1 equals to H11 I1 plus H12 into minus H21 by H22 I1 plus 1 by H22 I2. Now V1 equals to H11 I1 minus H12 into H21 by H22 I1 plus H12 by H22 I2. Now V1 equals to H11 H22 minus H12 H21 by H22 I1 plus H12 by H22 into I2. I'm naming this equation as sixth equation. Now comparing 5 and 6 equations with 1 and 2, that gives the Z parameters in terms of H parameters, that is Z11 equals to H11 H22 minus H12 H21 by H22, that is also known as delta H by H22. Now Z12 equals to H12 by H22, Z21 equals to minus H21 by H22, Z22 equals to 1 by H22. Thank you.